Okay, in this video, we will be solving this quaternary mixture in order to determine dew point temperature. And so let's look at this problem. We have compound A, B, C, and D, 4 compounds, quaternary mixture. The mixture obeys Raoult's law, and the molar composition Ya is 0.05, Yb is 0.1, Yc is 0.4, and Yd is 0.45. You add it up, you get 1. The mixture has a total pressure of 4 bars, and we want to determine what is dew point temperature of this mixture and the liquid composition that results. And formulas that we use for dew point mixture are these two, where we know the total of each component will add up to 1 for dew point. And likewise, we also want to know the liquid composition, and there's a rule for that. So XA, or liquid, is equal to Ya times P divided by PA vap. This problem involves Antoine's equation, so we'll use these 4 relationships. So we can actually determine PA vap is equal to, if we put a 10 here, we would get 10 raised to this piece, this piece, this piece, and this piece for PA vap, PB vap, PC vap, and PD vap. And by doing that, we'll only have one unknown variable. We'll just have T as unknown. We know Ya given, we know P, which is the total pressure given, and PA vap will be this relationship where ultimately the only unknown piece will be T, which is going to be dew point temperature. And we'll solve this problem in Excel. So kind of already did this in Excel, but I'm going to show you guys what we did. In a last video, a couple of videos back, we solved a similar problem where we had a tertiary mixture, where I kind of went step by step on how I got each component. But here I'm going to do a quick kind of refresher. So the factor that we're changing is temperature, and the way that I'm going to solve this problem is by kind of guessing intervals. I'm going to start off at 250 and go all the way to, I stopped at 345, and I went by 5s, 250, 255, 260, and so on. Next, how did I get PA vap? I used Antoine's equation, so I just put a 10 in the 10 raised to the piece. So 10 raised to, we were giving everything except temperature, T, and this is T. A2 is T. Likewise, if you keep on going down, you go A3, A4, A5, corresponding to the temperature. Same exact procedure where you go 10 raised to, Antoine's equation, where temperature is A2, then A3, A4, etc. Now XA. XA, this was the equation that we saw earlier. XA is equal to Ya times P divided by PA vap. So I'm pretty much just using that equation. Same for XB, XC, XD. And now I sum it. I sum XA, XB, XC, XD. And I want it to equal 1. So here, first one, when temperature is 250, you get 10. So I keep on going. I notice here, 310 and 315, it's between 1. So we have 0.94 and 1. So I know that the answer will be between 310 and 315. So in here, I start off at 314. I get 0.96. Then 313, I get 0.99. Then 312, I get 1.02. Then I go 312.5, and I get 1.007. So pretty much 1. And so I know dew point temperature will be 312.5. So this is the first answer. We want to know what is the dew point temperature. That's the answer. Next, we want to know the liquid composition. So we want to know XA, XB, XC, XD. And solving it in this format, we know here that XA, XB, XC, XD can easily be solved. So let's mark it. And so the answer for XA is this value, XB this value, XC this value, and XD this value. And that's all you need to do to solve this problem in Excel.